The changes in condition will make a system is no longer at equilibrium. The system have an ability to adjust itself and reattain equilibrium. This phenomenon is described by Chatellier's principle. When a chemical system at equilibrium is disturbed, the system will shift its equilibrium position in such a way to reduce the effect of the disturbance. So how is a system disturbed? At equilibrium, we know that the value of Q is equals to K. The system is disturbed when a change in condition forces it temporarily out of equilibrium. The three common disturbances are the change in concentration, the change in pressure by a change in volume, or a change in temperature. What does a net reaction means? So, the net reaction, it refers to the shift in the equilibrium position, whether to the right or left. The equilibrium position is defined by the specific equilibrium concentration or pressure. A shift to the right is a net reaction that converts reactants to product. A shift to the left is a net reaction that converts product to reactant. When a system at equilibrium is disturbed by a change in concentration of one of the components, it will react in the direction that reduces the change. Only the components that appear in Q can have an effect, so the changes in the amounts of pure liquids and solid cannot. The QC expression for this reaction is written as follows. When ammonia is added into the system, the concentration of ammonia will increases. This will make the value of QC decreases. So, the QC will become less than Kc. So, in order to remove the amount of the ammonia added, the equilibrium position will shift to the right until Q is equals to K. This will make the concentration of the product, which is nitrogen and hydrogen, increases and the concentration of the reactant decreases. When the product is removed from the system, the value of QC will decreases. So, it will make Q less than K. So, the equilibrium position will shift to the right in order to increase the amount of the product removed. This will make the concentration of the product increases and the concentration of the reactant decreases. But these two conditions won't affect the value of K, so the value of K remains unchanged. When ammonia is removed from the system, the concentration of ammonia decreases. So the value of the QC will be increased. Thus, Q is bigger than K. The equilibrium position will shift to the left in order to increase the amount of ammonia removed. Thus, the concentration of ammonia is increased and the concentration of our product here is decreased. If we add nitrogen or hydrogen into the system, the value of QC will be increased. So, the Q is bigger than K. The equilibrium position will shift to the left in order to remove the amount of the product added. Thus, it will increase the concentration of the reactants and decrease the concentration of the products. Again, the value of K does not change.